Here's our next one. This is 7.5, number 15. Tangent theta minus 1 plus square root of 2 equals secant theta. All right, somewhere I'm going wrong with this one and I'm missing a step or something, but I have an answer. It's just that you have to check the solutions to make sure they work. So we're in 0 is less than or equal to theta is less than 2 pi. And we know one thing. Maybe this tells us about our solutions. If tangent is positive, then it has to be bigger than 1, because negative 1 plus something smaller than 1, wait a minute, plus square root of 2 well, I don't know. Forget that thought. It was just a thought I had. I'm trying to justify why, and you'll see the answers at the end. When I plug them in, only one of them works. But we'll come to that, cross that bridge when we come to it. So I've already tried, one thing I tried is subtracting square root of 2 from both sides and then squaring both sides. It turned into a mess. So instead I'm going to try adding 1 to both sides and then squaring both sides. So if I add 1 to both sides, it is tangent theta plus square root of 2 equals secant theta. And who knows, there might be an easier way to do this. Maybe if you turn tangent into sine over cosine and secant into 1 over cosine, you get something easier, but I don't think so. Let's see, what would tangent? Sine over cosine, let's try that first. I'm just going to try that and then we'll go back. Sometimes you have to try different things and then I'll go back to the one that I think will work. All right, so we have tangent is sine theta over cosine theta, and then we'll subtract secant minus 1 over cosine theta equals 1 minus square root of 2. So I just put those onto the other side. So I get sine theta. I'm just adding, oh, they're already sine. They're already over a common denominator. So I have sine theta. Let me get more room here. Get rid of that. It is sine theta minus 1 over cosine theta equals 1 minus square root of 2. And sine theta minus 1 over cosine, I don't even know what that's supposed to be. That's getting us nowhere fast. Okay? Forget about it. I don't know what to do with that right now. So let's continue. We have tangent theta plus square root of 2 equals secant theta plus 1. All I did was add 1 to both sides. Now I'm going to square both sides. You can always square both sides of an equation or cube both sides. Raise both sides to the same power. It will remain equal. If I have, here's an example. If I have 2 equals 2, well then 2 squared, which is 4, equals 2 squared, which is 4. So I can always raise both sides to the same power. So what does this one come out? Well, just in case we need to see it, so we can FOIL it. There it is in all its glory. And I just want to look at something. I just wanted to make sure I was recording. All right, I'm doing this side first. Tangent times tangent is tangent squared. Plus square root of 2 tangent, and then outside times outside is square root of 2 tangent, gives us 2 square root of 2 tangent theta. So I'm just doing first times first. Inside times inside, that's square root of 2 tangent theta. Outside times outside, square root of 2 tangent theta. There's 2 square root of 2's tangent theta. And then last times last, square root of 2 times square root of 2 is 2. That equals, now I've got secant theta plus 1 times, and let's move over just to be cool, secant theta plus 1. So now I'm foiling it. Secant times secant is secant squared. Plus 1 times the secant inside, inside, outside, outside, 1 times secant, so plus 2 times secant. And then 1 times 1 is 1. Okay, so now I know that tangent squared theta plus 1 equals secant squared theta. So I'm going to take this 2 and I'm going to make it a 1 over here, and I'm going to put the other one over here. Just move it around so I can see it together. This first part, tangent squared theta, that's secant. Tangent squared theta plus 1 is secant squared theta. Plus 2 square root of 2 tan theta. I don't know if this is the easiest way to do it. It's certainly dropping some solution. Equals secant squared theta plus, this should be a theta here, plus 2 secant theta plus 1. And so now, notice there's a secant squared theta on both sides. If I subtract either one of them from both sides, they're going to cancel out. And there should be a plus 1 here. I missed this plus 1. So the 1's cancel out because there's a 1 on both sides of the equation. So now we're left with 2 square root of 2 tangent theta equals 2 secant theta. And now once again, square both sides. So there's probably an easier way to do it. I can't think of it right now, so I'm doing it this way, and you'll see what happens with some weird solutions at the end. I keep mentioning that, but we're going to have to plug them in and make sure they work. So what's 2 square root of 2 squared? Well, 2 squared is 4, square root of 2 squared is 2, times tangent squared theta equals 2 squared is 4, secant squared theta. 4 times 2 is 8, so I get 8 tangent squared theta equals, well, secant squared is tangent squared plus 1. So 4 times tangent squared theta plus 1. I'm just using an identity there. So I get 8 tangent squared theta equals 4 tangent squared theta plus 4 times 1 is 4. Now I can subtract 4 tangent squared theta from both sides. I get 4 tan squared theta equals 4. Divide both sides by 4. Tan squared theta equals 1. Square root both sides. Tangent theta equals plus or minus 1. Where does tangent theta equals plus or minus 1? Pi over 4 if you look on the unit circle. And now I've forgotten them already, so let me find it. Where is my unit circle? I had a unit circle somewhere. What did I do with the unit circle? All right, let's try this. Unit circle. We have to get to the unit circle. So tangent theta is 1 here at pi over 4, and then here it's minus 1 at 3 pi over 4. And then it's 1 again at 5 pi over 4. And it's negative 1 again at 7 pi over 4. Now let's write our original equation. Our original equation, and again, I don't know why this has happened. Something got dropped or missed with our manipulations, but if you plug these back in, all right, so pi over 4. Tangent of pi over 4 is 1 minus 1 plus square root of 2 equals secant of pi over 4. Here's pi over 4 is square root of 2 over 2, but flipped. So 2 over square root of 2. And if you multiply that by square root of 2 over square root of 2, you get 2 square root of 2 over 2 equals square root of 2. So 1 minus 1 is 0. Square root of 2 equals square root of 2. Pi over 4 works. Let's try 3 pi over 4. Tangent of 3 pi over 4 is going to be square root of 2 over 2 over negative square root of 2 over 2 is negative 1. So negative 1 minus 1 plus square root of 2 equals, and then secant of 3 pi over 4 is negative 2 over square root of 2, which is negative square root of 2. All right, so 1 minus 1 is minus 2 plus square root of 2. Does not equal negative square root of 2. So 3 pi over 4 doesn't work. 5 pi over 4, tangent is 1, so 1 minus 1 plus square root of 2 equals secant of 5 pi over 4 is again negative square root of 2 because the cosine is negative square root of 2 over 2, and square root of 2 does not equal negative square root of 2. So 5 pi over 4 does not work. And then 7 pi over 4. The tangent is negative 1. We get negative 1 minus 1 plus square root of 2 equals, the cosine is square root of 2 over 2, square root of 2 over 2. So the secant is square root of 2. Remember I showed you here how to go from 2 over square root of 2 to turn it into square root of 2 by rationalizing the denominator. And negative 2 plus square root of 2 does not equal square root of 2. No. So again, 7 pi over 4 doesn't work. Where we went wrong, I don't know where in our manipulations we dropped whatever it is that would make our solution only pi over 4. And maybe I'm missing something that tells us that we have to be in the first quadrant. I don't know. But the point is, if you plug in all of these answers that we got, only one of them works in the original equation. So sometimes you have to do that. How do you know in this case that you had to do it? I'm not sure, but you did. So if you plug in all those equations where tangent theta equals plus or minus 1, only pi over 4 works in the original equation, which is tangent theta minus 1 plus square root of 2 equals secant of theta. So pi over 4 is the answer. And they don't ask for answers forever. They ask them from only 0 is less than equal to pi is less than equal to, or less than equal theta, less than equal to pi. So that's their answer. Only pi over 4. Weird one. Not quite sure. I'd have to look at it some more to see why we can't drop those immediately or do something with a manipulation that doesn't come up with those. But if we plug all our answer choices back in, which you should do anyway, you will find that only pi over 4 works. And you can verify that with Wolfram alpha by typing in this equation. So there's your answer for whatever one this is. 7, 5, number 15 is pi over 4.